Alright, so to scale something means to make it, to start with something and make it bigger or smaller. You know, scale it up or scale it down. You might have heard. Um, and so a scale drawing, for example, um, is a massively scaled down version of a real object. So, for example, say I've got a sperm whale here in real life. Actually, this is just a picture of a sperm whale, which is itself a kind of scale drawing of the real object. Anyway, imagine this is a real sperm whale, gigantic. Um, this over here is a scale drawing, uh, which means I've taken the real measurements on the whale, um, and I've scaled it way down. So here's the scale of the scale drawing, 1 to 200, which I could write as a fraction, 1 over 200, which means whatever length over here I have, I scale it by a factor of 1/200th, or I multiply it by 1 over 200, which is also, as a decimal, is 0.005. So let's say I don't know how long the sperm whale is. Well, let's say I measured it for whatever reason. I measured it as 400 inches long, all the way across. Well, the scale would say take that divided by 200, or in other words, multiply by 1 over 200, and then that's the length on the actual scale drawing. So if this is 400 inches, then on the scale drawing, this would be 2 inches, which it's obviously not. It's much bigger than that. I'm just pulling numbers off the top of my head, but you get the point. This thing is called the scale factor. It's the factor by which I scale something up or down. So in the case of making a scale drawing, I'm taking the measurements of the real object, and I'm scaling it down to make a scale drawing of that object. So, I measure this however long it is, then that length I multiply by 1 over 200, also known as 0.005, and I get the corresponding length on the drawing itself. So I know how to draw it so it looks accurate and everything. So this is called a scale factor, 1 over 200 or 0.005. That's the scale factor of this scale drawing to the real object. Scale drawing to the real object. Something that's a length of 1 on the scale drawing, let's say that's 1 centimeter. The corresponding length on the whale would be 200 centimeters. Okay? So let us find a couple more scale factors. So I've got this drawing here, but you can do this with word problems too. Okay, so I don't know if you've heard of the old Saturn V rockets. That's what we used to get to the moon. Biggest machine ever created by humans. Real Saturn V rockets were 42 meters tall. The real thing is 42 meters tall. So let's put the real measurement on the bottom. You've got a scale model of a Saturn V that is 21 centimeters tall. So let's find the scale factor. Now, first of all, I kind of threw you a curveball here. These units are not the same, so we need to make them the same before we proceed, so we can see what the scale factor is. 1 meter is 100 centimeters. So what I'm going to do is I'm just going to convert this bottom to centimeters. I think that'll be the easiest. So 1 meter has 100 centimeters. So 42 meters would have 4,200 centimeters. Okay. So now since the units are the same, I can just cancel them out and just say the scale factor is 21 to 4200. Now I should reduce that. I should reduce that. So just to get it in the simplest form, so I could factor this out. That is, what is that? That's, I could pull out a factor of 21 times 200. Yeah, 21 times 200 is 4200. So I could cross off these 21s, so that would be a scale factor of 1 to 200. I don't know, did I do that on purpose? Same scale factor as the whale? I might have done that on purpose. Maybe I didn't. Alright, so that's the scale factor, 1 to 200, or again, you can convert that into a decimal if you wish, scale factor of the scale model to the real thing, 0.005. Alright, scale factor. So that's if you were to measure something on the real object and you wanted to draw something that accurately represents that, you would multiply the real length by the scale factor. That's why it's called scale factor. So in this case, 0.005. Alright, a scale model, let's look at this last one. Scale model of a house is 100 times smaller than the real house. So we want the scale factor of the scale model to the real house. So of the scale model to the real house, so if it's 100 times smaller, what we could say is the real house would be 100 and the scale would be 1. So saying it's 100 times smaller is the same as saying that the real house is 100 times bigger. Does that make sense? So the scale factor of the scale model of the house to the real house would be 1 to 100, which you can turn into a decimal if you want. 0.01 if that makes you feel better. So what would that would mean is you could measure something on the real house, like say you've got a window that's, I don't know, let me think. Say you've got a room that's 50, say you've got a big room, it's 50 feet across. In the scale model of the house, the length of that room would be 50 times 0.01, 50 times the scale factor. So you'd be scaling it down to represent it in the scale model. So yeah, so that'd be 0.5, I believe. Yeah, 0.5 feet. 6 inches, half a foot, 6 inches. Yeah, so that's how you find the scale factor, and that's what you do with it.